Let's take a look at independent and mutually exclusive events. Two events, A and B, are independent if the knowledge that one occurred does not affect the chance the other occurs. So two events are independent if the following are true. If the probability of A given B equals the probability of A, and the probability of B given A is the probability of B, and the probability of A and B equals the probability of A times the probability of B. So stay with me. For example, the outcomes of two rolls of a fair die are independent events. The outcomes of the first roll does not change the probability for the outcome of the second roll. Right? Just because you roll a die and you get a 2 doesn't mean the next time you roll it that you're going to get a 2 or that it's affected by your first roll at all. So that's why they're independent. To show two events are independent, you must show only one of the above conditions. If two events are not independent, then we call them dependent. So you can sample with replacement and without replacement. So with replacement, if each member of a population is replaced after it's picked, then that member has a possibility of being chosen more than once. So when sampling is done with replacement, then events are considered to be independent, meaning the result of the first pick will not change the probabilities for the second pick. But when your sampling is done without replacement, each member of the population may only be chosen once. In this case, the probabilities for the second pick are affected by the result of the first pick. The events are considered to be dependent. So you have a fair, well-shuffled deck of 52 cards. Suppose you sample 4 cards without replacement. Which of the following outcomes are possible? It says answer the same question for sampling with replacement. So first we look at without replacement. So that means we can't pick the same card twice because once we pick a card, we set it aside and it's no longer part of the sample. So Queen of Spades, 1 of Diamonds, 1 of Club, Queen of Diamonds. So that could be possible. King of Hearts, 7 of Diamonds, 6 of Diamonds, King of Heart. Nope, this one could not be possible. Queen of Spades, 7 of Diamonds, 6 of Diamonds, King of Spades. Yes, that could be possible. And then with replacement, any of these 3 could be possible. Now let's talk about mutually exclusive events. A and B are mutually exclusive events if they cannot occur at the same time. So this means that A and B don't share any outcomes and that the probability of A and B is 0. So they have nothing in common. So suppose the sample space equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And A is 1, 2, 3, 4, 5. B is 4, 5, 6, 7, 8. And C is 7, 9. A and B is 4 and 5. So the probability of A and B is 2 out of 10, and it's not equal to 0. So A and B are not mutually exclusive. A and C, however, do not have anything in common. So the probability of A and C equals 0. So A and C are mutually exclusive. If it's not known whether A and B are mutually exclusive, assume they're not until you can prove otherwise. So let's look at another example. We're going to flip 2 coins. It's an experiment. The sample space is heads, 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 tails, tails, heads, and tails, tails. So the outcomes are equally likely. If A equals the event of getting at most 1 tail, then A can be written as HH, heads, 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 tails, or tails, heads. The outcome, heads, heads, shows 0 tails. Heads and tails and heads each show 1 tail. Let B is the event of getting all tails, and B can be written as tails, tails. B is the complement of A, so B equals A prime, right? No part of B is in A. So we also know that the probability of A plus the probability of B is the same as the probability of A plus the probability of A prime, which is equal to 1. So the probabilities for A and for B are, the probability of A is 3/4, the probability of B is 1/4.